Hello guys, welcome. Today we are going to talk about something called fronts. We have covered air masses so far, and we have studied about what can represent an air mass, specifically the two letters. And we know that air masses have two characteristic features. One is the moisture content, and the second is the temperature. Depending on these, we can have different types of representations. It can be maritime polar, maritime tropical, continental polar, continental tropical, and so on. And today we're going to take this one step further and learn about something called fronts. Now, fronts are normally found in areas um, with middle latitudes. So it's associated with weather in the middle latitudes. Now, air masses that form in different areas don't actually mix very well with each other. And the reason why that is so is because of the changes in temperature or density. So if it's a warmer air mass, it will probably be less dense because it is lighter and will probably rise higher in the atmosphere. And if it's a colder air mass, it is probably heavier and will probably sink down in the atmosphere. This is why it doesn't really mix very well. Now, so when two different types of air masses meet, warm air, as you can see in this image, generally rises. And the area in which the two different types of air masses meet is called a front. Now, in this picture, you can see that this is the area where the two different types of air masses meet. So this is the front. Now, again, there are four different types of front. The two that you can see here is two of the four. So there's a cold front and there's a warm front. Now, a cold front is a front where cold air moves under the warm air, which is less dense. So the warm air is less dense of the cold air mass. And this is why the cold air kind of pushes the warm air upwards, as you can see from this arrow. Now, the direction of this front is towards the right. And cooler weather usually follows a cold front because the air mass behind the cold front is actually cooler and drier than the air mass that it is replacing. These actually kind of move very quickly, and they also bring thunderstorms, heavy rain, or even snow, as depicted by the image over here. These this shows that the air is rising up here and the cold air mass is replacing it or by pushing the warmer air upwards. Now, when we move over to the warm front, this normally forms where warm air moves over cold or denser air. As you can see in the image here, you can see that it's kind of pushing up on the colder air mass and is moving up. And again, the direction of the front is towards the right. It generally ends up bringing a drizzly rain, but is always generally followed by clear and warm weather. As you can see over here, there's some rain, so we can predict that. And this image is a pretty accurate depiction of what a warm front technically looks like. Now, let's move forward and learn about the other two types of fronts. They are occluded front and stationary front. Again, we have pictures over here. Now, stationary front has its name because it's stationary, as in like it's almost in place. But on the other hand, occluded front is a little more complicated. Let's look at them one by one. Now, an occluded front kind of forms when the air mass is actually caught in between two colder air mass. So as you can see in the image here, there are two different cold air masses, and you can see that it is trapping the warmer air mass in between them. So this is why there is an occluded front. Now the coldest air mass obviously moves under and pushes the warm air upwards, as you can see here. And the coldest air mass moves forward until it meets another cold air mass. So it's pushing forward until it meets this air mass, this cold air mass. And one of these is warmer than the other and is less dense. So that will probably be pushed upwards as well. Now, the colder of these two air masses moves under, and the warmer of these two cold air masses again rises upwards because of its density. But sometimes it is possible that these two kind of mix with each other rather than pushing one of them upwards. And this can be due to various reasons. It could be due to an equal moisture content or temperature. So it kind of allows similar densities allow for the mixture to happen. And that can happen sometimes, but not always though. So yeah, so this is when the warmer air mass is kind of trapped in between two different cold air masses. Again, the direction of the front is towards the right, so you can see the cold air pushing towards the right until it meets another one. And that brings us to the fourth and final air mass, which is the stationary, sorry, not the air mass, fourth and final front, which is the stationary front. Just like the name says, it depicts some kind of stationary air mass. To be specific, a stationary front actually forms when a cold air mass meets a warmer air mass. As you can see here, the cold air mass is meeting the warmer air mass, and this results in a stationary front. And in this case, to be known as a stationary front, what happens is that the air masses don't have enough force in them to lift the warmer air mass over the colder air mass. So it kind of just stays in place, but still separated. Um, and this can actually happen due to several reasons. This might happen if there's not enough wind to keep the air masses separated. And it can happen if there's not enough wind to keep them pushing against each other. Stationary front often brings many days of cloudy and wet weather, as again you can see there's a lot of heavy rain, and there is a huge cloud. And that is a stationary front. And we learned about the four different types of fronts. We learned about cold front, warm front, occluded front, and stationary front. I hope you have a great day, and I will see you later. Bye.